Hello Algebra 2 students. In this video, we're going to go over a review for quiz on section 2.1 to 2.6. All right, so I have out my notebook, pencil, calculator, right, and also this chart. Hopefully you have it down somewhere from the previous lessons, but this chart of like perfect squares and cubes, fourth powers, pretty useful. So I might actually copy it down here because we're probably going to use it in some of the questions here. So hopefully you've got it written down somewhere. Otherwise, maybe I'll reference it throughout the video too. But it's pretty useful for these simplifying radical questions. Okay, so we're going to go back and start with what we did in 6.1, which was just to find the values of different radicals. Okay, and certainly you can use calculators to help. Just remember there's that little chart about how many solutions it has, right? So whether or not the index number is even or odd, and then if the number underneath there called the radicand is positive or negative, that'll drive how many answers you have. Because you either have 0 answers, 1 answer, or 2 answers. Okay, so I would pause the video and try these before continuing. All right, so the first one is even. It's an invisible 2, so it's an even one, and it's a negative underneath there. So that is no real solutions. Right, we learned earlier that that would be imaginary numbers, but for this chapter, we're just going to call that no real solutions. Okay, the next one is also even. It's 4, and it's positive this time. Underneath, this thing is positive. So we're going to have 2 solutions. Okay, so I might write as well right now, write down just plus or minus. Okay, and then the way this actually works is if I'm thinking about this as a fourth root, I've got to do fraction times fraction times fraction times fraction. That equals 625 over 81. So basically, you just need to do like the fourth root of 81, which I think is 3. 3 times 3 times 3 times 3 will give us 81. So that's going to be the bottom number in our fraction. And then the top number would be like the cube root of 620, sorry, a fourth root of 625. And I'm going to guess that this is 5. 5 times 5 times 5 times 5, right? And just to verify that, maybe I'll check on my calculator. All right, so to do this, I'm going to type 4 because I got to do a fourth root. And then I'm going to hit the math key. And then number 5 will let me do any root called x root. So I'm going to hit 5. So now I'm doing a fourth root. And now I'm just going to type 625. Just kind of check to make sure that that is indeed 5. Okay, so I'm really doing like the fourth root of 625 and the fourth root of 81, and that gives me my 2 answers here. Plus or minus the fraction 5/3. Okay, odd one. So this is an odd one because it's the third power. Always has 1 answer. Whether or not the radicand underneath here is positive or negative, it always has 1. Okay, so for this particular one, it's going to have 1 answer, and we could use our calculator or our chart. Maybe we're going to use the chart on this one. So 216 is 6 cubes. So if I do the cube root, I'm going to get 6, or in this case, negative 6. All right, so this one has 1 answer, and in particular, it's negative 6. Okay, and if that's confusing, just kind of think of it in terms of what a third root is. All right, if I made 3 blanks here, it would work negative, because if I do negative 6 times negative 6, that would be positive 36. Then you take that times a negative 36, we're back to a negative number. So it makes sense that negative 6 is the right answer here. Okay, last one. Again, you could do a plus minus here. But really we're going to do them sort of individually. So I'm going to do a fourth root of 256, which I think is 4. I don't know. I'm going to go back and look actually. So here's my fourth power is 256, and they go all the way across is 4. So the fourth root of 256 is 4. So I got 4, and then this 4 evenly divides the x to the 8th and y to the 12th. So that will make it just divide them out to 8 divided by 4, 12 divided by 4. Okay, and so that's what our answer looks like there. Okay, and that's really the main thing, is to work on these simplifying these radicals. And this one was nice and neat because this index evenly divided the 2 exponents. That makes it kind of easy. So the next slide is going to talk about when that doesn't happen. Okay, so I got a couple for you to try here. The first one hopefully is pretty straightforward, but pause the video and try them, and then on pause to see your answers. Okay, so the first one, the index evenly divides both of these. So we can just write it as 9 divided by 3 and 12 divided by 3. So that is our solution. Okay, and then on this third root question, because it doesn't divide it evenly, 3 does not evenly divide 11, I have to split it up into two parts, just like when we did, like root 50, we would divide that into the perfect and the non-perfect part, like 25 and 2 or whatever, to give us 5 radical 2. We're going to do that same type of thing. Sorry, that 5 doesn't look very good there. Same type of thing here, all right, where this is, we want to make it so it divides evenly like it does over here. Okay, and so we're going to put some of our x's here and some of them here, just like we did on this question. And also similar, it has to multiply to x to the 11th. So some examples would be like x to the 10 and x to the 1, x to the 9 and x squared. And I'm just kind of going backwards, right? X to the 8th, x to the 3rd. If you multiply those, you would add the exponents and they'd add up to 11. Okay, so we want to use the highest one where the front is divisible by 3. So 11 doesn't work, and 10 and 1 wouldn't work because 10 is not divisible by 3. But if I go back one more, x to the 9th works, right? And then our leftover, we have an x squared. Okay, so like some students might do like x to the 6th and x to the 5th, and that's right in a sense. But we want the highest one up here that's divisible by 3. So 9 and 2 will work, and then when we divide this out, we get an x cubed, right? This index divides the exponent now, and then our leftover stuff doesn't divide out evenly, and so we just leave it as a cube root of x squared. Okay, so last example here, and again, if you feel like you didn't get this before, but you feel more comfortable now, you could maybe try it. First thing to note here is our index is 2, right? If nothing's written there, it's 2, and it doesn't evenly divide these. Okay, so I'm going to make a perfect part and a non-perfect part. And I'm going to split up my x to the 7th. And again, my choices would be like 6 and 1, 5 and 2. They just got to add up to 7, 4 and 3. And I want to use the highest one for x that is divisible by 2. So it's actually this first one up here. So I'm going to do x to the 6th here and x to the 1st here. Remember, again, those add up, right? X to the 6th times x to the 1st is x to the 7th. Okay, and then for the y's, again, like I just kind of count backwards. So 9 doesn't work. If I go back to 8, that is divisible by 2. So I'm going to put y to the 8th here, and then I'll have 1 in my leftover pile. Okay, and now the index divides out evenly, so we get x cubed and y to the 4th. And then our leftover x times y. All right, and that's the cleaned up part. We have the part that cleaned up and then the non-perfect part, just like we did back here with root 50. Right, I think trying to reference this is very helpful for these questions. Okay, so next up, a couple more simplified ones for you. And again, you always want to break it into the perfect and non-perfect part, even though number 5 will start a little bit different here, but that's the idea. So pause the video and give this a shot. Okay, number 4. So I'm going to make a couple thirds for my perfect stuff, my non-perfect stuff. And I kind of do it in parts. So 81, I don't think is a perfect cube number. I'm going to go back and look. Okay, so 81, here's my cube list. It's not on there. So I have to find one that does divide 81 evenly. So like these are too high down here. 64 doesn't divide it evenly, but I think 27 does. Right, again, I'm using my cube numbers because it's a cube root. Okay, so what happens here is I can break it into 27 times 3, where 27 is my perfect cube. Okay, and then for the other parts, I'm going to do the same variable thing I was doing on the previous slide. And for x to the 9, that is divisible by 3, so I can have all x9 up here. Sorry, that's supposed to be an x. Okay, and then the y's, 8 isn't divisible by 3, so I'm just going to count backwards. So again, I could do like 7 and 1, but 7's not divisible by 3, so if I try 6 and 2, again, I'm counting back from 8, and that does work. I'm going to put y6 here so that I'll divide evenly, and then I'll have 2 in my leftover pile, sometimes called the dumpster fire. Okay, and now these perfect cubes, I can simplify that. So cube root of 27 is 3, and then 9 divided by 3 is x cubed, and 6 divided by 3 is 2. Okay, and then here's my dumpster fire leftover cube root of 3y squared. Okay, so 5, what's kind of different here is it's a multiply question. So basically, this is the accordion that I always talk about, where I'm going to smash them together first. Just like I can pull them apart into 2, like I did on number 4, you can also smash them together. Okay, to get root 24. And now I want to see, are there any perfect squares now that I can split? So I'm going to smush it together and then split it back apart. And there's still going to be numbers that multiply to 24, just like 8 and 3 are. But now I want to put one of them a perfect square. Right? So if I use my list of squares like 4, 9, 16, 25, the one that's going to work I think is 4. So 4 and 6, so that becomes 2 radical 6. Square root of 4 is 2. Right? And so that cleans up as much as we can. Okay, and we know we're done because there's no perfect squares that'll evenly divide the 6. So our final answer, I'll try to write a little neater there, is 2 radical 6. All right, division is up next. Okay, and so we don't want to do that rationalize the denominator thing unless we have to. So pause the video and see if you can figure out how to do this one. Okay, so the trick is on any division one, I would first do this, like make it into one big check mark, just like you can pull apart and smash together and multiply, we can make it into one here, right? And the reason that's helpful is 324 is divisible by 2, and so we no longer have to really deal with the denominator, right? When that divides out, that comes up to 162, I think. Okay, and now it's just like all the questions where we don't want to leave our answer here, right? We want to simplify it. So I want to do a perfect cube part if there is one. There might not be a cube that divides it, but pull it apart. And this is where I'm going to need that list. So I'm going to see if I can paste it in here quick. See if it's going to work. Sorry, one moment, please. All right, there we go. So I covered up everything, but yeah, can I move this? I'm sorry for the technical difficulties here. Well, maybe give me one sec. Okay, and I just realized I messed this up. I should have been doing a 4th root, not a 3rd root. So I gotta erase all this, but I'll still use my chart. So, all right, anyways, this is a 4th power, so I want to use my x to the 4th table here. Okay, so I'm going to start looking through my 4th power numbers. 256 is too big. 81 I think works right away, so actually I can just do 81 times 2. And then my 4th root of 81, if I just come across here, is just 3. So this 4th root of 81 cleans up to exactly 3, and then I have a 4th root of 2 left over. Okay, sorry for all the difficulties on that one, but hopefully that's the right answer now. Okay, one final divide one for you to try. Okay, so this is going to start the same way, where I'm going to make it into one big division question and see if I can simplify stuff at all. Okay, and it looks like we're in luck. 375 is divisible by 3. I think you just get 125, so that's great. I think that's even, I don't know if that's really not a perfect cube number. Or is it? Yeah, it is actually. That's 5. Cube root of 125 is 5, so that's great. And then my x's I'm just going to subtract. So 10 minus 2, I get x to the 8. Okay, and now like all the questions, right? This is why that simplifying is so important, is you got to split it into the perfect and non-perfect. And 125 is already perfect, so that's great. And then 8's not divisible by 3. So we've done this a bunch in this video already. I'm going to count backwards. 8, 7, 6. I'm going to go until I get one that is divisible by 3. Right, so that would be 6 here and then 2 in the leftover. Right, so this now cleans up. Cube root of 125 is 5. Divide the exponent by the index, so get x squared. And then we have a leftover part, cube root of x squared. Right, and that is it. So divide it a little bit and then clean it up from there. All right, thanks for watching.